get as an answer here? Negative 5n plus 19. Did everybody get that, or do I need to go through it? Because we can go through it real quick. Okay, awesome. Then this one was arithmetic, so that's why. Now, I want you to notice something. If it's arithmetic, the formula, the explicit formula will be linear. Always. Degree 1, so that makes it linear. Just so you know. So then, right here, this was geometric. What did you get? A sub n is equal to 1 times negative 3 raised to the n minus 1. Good. And you could just put, which it's fine if you left it like that. That's great. You also could have just put negative 3 and minus 1. You just need to make sure that negative 3 kind of stays in parentheses, because your calculator will not know to also take the negative and square it, for example, or whatever. Does that make sense? Okay, awesome. Good job. Way to go. So that'll allow you to find any term in the sequence. And then notice geometric will always have, it'll always be like exponential. Do you see how this is an exponential function? That's what makes it geometric. Okay, so what is the difference between a sequence and series from last time? Let's just do a quick review. Yeah. Yeah, perfect. Sequence is just a sequence of numbers, just like you said, and the series is adding them up. Very good. There are geometric series and arithmetic series, and there's geometric sequences and arithmetic sequences. You've got to determine the difference, because they're different formulas. Okay, what's the difference between a finite series and an infinite series? Yes. Okay. So right here, yep, you're right. This has a start and end, so it's finite. And this has a start but no end, so it's infinite. That makes sense. Infinity, it's going to infinity. Everybody understand? Very good. All right, so what I want you to do is see if you can remember how to find the sum. So I want you to notice, this is arithmetic. 8 minus 5 is 3. There should have been, and then 11 minus 8 is 3. Does everybody see how I can say, oh, this is an arithmetic series? It's a series because we're adding. And then you'd say, it's finite, so I can find the sum. Here's the start, a sub 1, and here's the end. Here's a sub n. So then, can anyone remember the formula from last time? The sum of this many terms is equal to n over 2 times, very good, the first term plus the last term. So ready to go. Find the sum real quick. So first of all, we're going to have to figure out how many terms we're summing up. So remember how we learned that last time. 258? Okay, 258. Awesome job. Okay, I saw Cassandra do this absolutely correctly. She said there's a distance. We started with 5. I got to 38. How much distance does that cover there? 38 minus 5 is 33. But that would be moving in ones. We're not moving in ones. We're moving in threes. Correct. So how long did it take us to get to 38? Well, there was 33 units divided by 3 because we were moving in units of 3. That's 11. That means we started with 5 and added 3 11 times, and that put me at 38. So a total adding of 12 terms. So the sum of 12 terms, is equal to 12 divided by 2 times the first term, which is 5, plus the last term, which is 38. Very good. And we get that. Okay, question. Some of you did that completely wrong, so make sure you're understanding how to use that formula. Okay, and then this one. You can do it 2 ways. I want you to do it by hand, not by calculator. Ready, set, go. So it's arithmetic. Notice it's linear, right? The explicit formula is linear. So you say, oh, that is arithmetic. So that means I'm going to use that same sum formula. Everybody pay attention because it's obvious that we're struggling. First of all, we've got to figure out how many terms we're summing up. Is it the first thing we're plugging in a 4, you guys? We're not starting with 1. So we're not plugging, this is not 11 terms. So think about it, guys. You plug in a 4, you get something. 5 something, 6 something, 7 something, plug in 8, 9, 10, 11. How many terms is that? 1, 2, 3, 4, 5, 6, 7, 8. Does everybody understand? Now, the easier way of doing it, instead of having to write that out, even though if I was desperate, I could do that and think of it that way. But you can do the top minus the bottom, because that's the distance, right? What's 11 minus 4? 7. And then add 1 is 8. So you'd say, I'm summing up 8 terms. That's equal to 8 divided by 2 times, I need the first term. Well, isn't the lowest thing in my sequence going to be plugging in the lower limit? So you plug in 4 there. So that's 8 minus 3, which is 5. Then plus the final term, well, think about it, guys. You're going to be plugging in the largest thing here. So 22 minus 3 is 19. And that's all you had to do. Type that in, and you're there. Everybody good? You got it? Nice. I know some people had it. I saw a few people. Very good job. So what was the answer? Okay, very good. So those that got it. Hopefully that was a good review because you've got to know that stuff, and then today we're learning more. Okay, all good. Okay, let's get going with what we're doing today. You're going to want to take some notes. Today's probably one of the harder days. And then next time will be the review, the next time will be the test. Okay, so today we're going to be dealing with geometric series. Last time we did arithmetic series, now we're going to be dealing with geometric series. Here's an example of a geometric sequence. It has a common ratio. That divided by that is 2. 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 It's a sequence because it has commas. Here's an example of a geometric series because it still has a common ratio of 2. We're still dividing by 2 between each of these. It's just we're adding them up, so we're summing them up. So same idea as with arithmetic. Okay, so if we're going to start out with finite geometric series. So if you know the start and end, then it's finite. If it's geometric, to find the sum, you use this formula. So you should have your formulas worksheet out maybe to help you not have to write it down again. So the sum of this many terms, so n is the number of terms you're summing up, is equal to a sub 1, the first term, times 1 minus r raised to the n, divided by 1 minus r. So a sub 1 is the first term, r is the common ratio, and n is the number of terms you're adding up. Notice how I have parentheses. You're going to want to use parentheses when you type it into your calculator, especially on bottom here. So you're just going to be really careful when typing it into your calculator. But really, it's just plugging it into the formula and going for it. Yes. Yep, just like with arithmetic. Good question. Yep. So that'll be very similar, exact same thing as arithmetic. All right, here we go. So look at my example. This one's not on your worksheet. Just look. You don't even need to take notes if you don't want. Just look. So here's my first example. We have, if we wanted to sum this up by hand, try to get it into our calculator, that would be easiest, right? Obviously, because it's so straightforward. However, let's use the formula to practice for harder ones. So we're summing up 1, 2, 3, 4, 5, 6 terms. So we'd say the sum of 6 terms is equal to a sub 1, the first term, which is 3, times 1 minus, what's our ratio? 6 divided by 3 is, 12 divided by 6 is 2. So it'll be 1 minus 2 raised to the n, which is 6, divided by 1 minus r, which was 2. Now you would just type it in. Really quick practice, because it's really kind of tends to be the hardest part, is typing it in correctly. Now here's why. You're going to maybe want to calculate the top, hit enter, then divide it by, and then put it this bottom in parentheses. Okay, 189. And then we can check our answer by actually adding those up, and it looks like it's going to come out right. Everybody good? Okay. Perfect. Let's go on. Did it come out right? Yeah. Okay. All right, let's do this one. Everybody, once again, just watch. Don't take notes necessarily. We're summing up 1, 2, 3, 4, 5, 6 terms, correct? So the sum of 6 terms is equal to 6 divided by 2. Nope, that was arithmetic. Started going too fast. So geometric, a sub 1 is, yep, negative 15 times 1 minus our common ratio, which is negative 2, isn't it? So you'll do parentheses -2 raised to the 6 divided by 1 minus -2. Let's see if we can get that one right. Ready, go. I didn't get that. Make sure you use all the parentheses I used here. Because -2 to the 6th power, isn't that going to become positive? You've got to use parentheses exactly as you see it. You should have got 315. Okay, perfect. So now notice something. If you have to be really careful, because here's the thing, guys. I want you to notice that the -2 I put in parentheses. If you would have just done this, 1 minus -2 to the 6, it would have changed that to plus and plus, your calculator. Does everybody see? But that's really not what we're dealing with, because it's 1 minus -2 to the 6, which is going to become positive. So that's still going to be a subtraction sign. You've got to be like so particular about putting things in parentheses. Does that make sense? Okay. Did you all get it? Okay, perfect. Okay, so let's do the hardest one of them all. So we're dealing with a problem here. We know it's geometric, so look, this divided by this is 2, this divided by this is 2, this divided by this is 2. Now here's the problem. We're seeing what we saw with arithmetic in this one. We know our first term, but we don't know how many terms we're summing up, right? We know this is a sub n, but once again, we don't know how many terms we're summing up. Everybody understand? So it's not going to be the same. You can't do the distance and then do the divided thing, because that won't work with geometric. So the only way to do it is to say, okay, what was the explicit formula that generated this particular sequence? So let's try and write out an explicit formula. So a sub n is equal to a sub 1 times r raised to the n minus 1. Isn't that the explicit formula? Okay, so now we know that a sub n is 3072. And then a sub 1 is 3. We know our common ratio is 2. And we don't know n, right? Isn't that what we're looking for, is the number of terms we're summing up? So n minus 1. And now look at my equation. I only have one unknown, n, yes. Because we're trying to find the n that will put us at this. Does that make sense? So we could have put any, but then that would have told us what term we were at. Does that make sense? Good question. The reason I'm choosing this to be a sub n is I'm saying, what n did I plug in to get this? Good question. Okay, so let's solve for n. So what would be my first step algebraically? Let's see if you're going to be okay next year in pre-calculus. What do I do first? Solve for n. We've learned this. Not quite. You what? Guys, it's just algebra. It's not a trick question. How do we get n alone? First step. Divide both sides by 3. Okay, type that in. Go. 3072 divided by 3. What is it? Okay, 1024 is equal to 2 raised to the n minus 1. Would it be appropriate to divide by 2? No. Good. You guys remembered. We learned this. It's exponential, isn't it? Anyone remember how to get rid of base 2? Hey, you guys are so smart. You're right. The only way to undo base 2 is log base 2, right? So we're going to log base 2, both sides of the equation. That cancels out with that. So now we have log to the base 2 of 1024 equals n minus 1, correct? Can we type that into our calculator? No, so can anyone remember what we did too? Type it in. Perfect. She's got it. It's the change of base formula. So we do log of the big thing divided by log of the small thing. So we would do log of 1024 divided by log of 2. And that equals n minus 1. So type that in and then add 1. There's n. N equals 11. We don't need to add 1. Didn't we solve specifically straight for n? Does that make sense? So it's 11 terms. Because once again, this one we solved straight for n. N is the number of terms we're summing up. Oh, I meant like, oh, sorry. You did add 1 here. But I mean, this is my answer. We're summing up 11 terms because we solved directly for n. Log the base 2 of 1024. You can't type it into your calculator. So you use it's called the change of base formula to rewrite it. Okay. So we did add this one. What I meant is we don't add 1. You know how with all the others we've been adding 1 to how many terms? Sorry, that makes sense. No, that was good. That was good clarification. So I'm like, wait, what? Okay, good questions. Yeah, good questions. We would add 1 to this, and then here's our answer, 11. Good question. All right, so we're summing up 11 terms. So now we can actually begin. So we'd say the sum of 11 terms is equal to a sub 1, which is 3 times 1 minus our common ratio 2 raised to the 11th power divided by 1 minus 2. And then you would type it in and you should get 6,141. Is everybody good? Okay. Ready, set, oh, 1 more than the rest, and then I'm going to give you time to do 1 through 7. So looking at this one, what I want you to notice is it is considered geometric because we have an exponential here. Now think about why that would work. Isn't this our starting term? Everybody? Like initial value, think about exponentials. Initial value, isn't this our growth or decay factor? So we're growing, well technically, but it is still growth because remember you look at the absolute value. So this is a growth of a factor of -2. Does that make sense? It's getting exponentially larger but in the downward direction. Okay, so this is exponential growth, which makes sense, guys. Think about it. If we plug in a 1 here, what's my first thing going to be? My first term? 5, correct? Look, 1 minus 1 is 0. -2 to the 0 goes away. Does everybody understand? Then if we plug in a 2, that would be 5 times -2, which is -10. Do you guys see what I'm doing? And then plugging in a 3, that would be squared. -2 squared is 4. 4 times 5 is 20. So let's figure out my factor. 20 divided by -10 is, -10 divided by 5 is, do you see how it makes it geometric? Okay, so now we can find the sum using that formula. So how many terms are we summing up? Same rule applies here as with arithmetic. How many terms are we summing up, guys? 10. We plug in 1 through 10, wouldn't we? Should be summing up those things. So you'd say the sum of 10 terms is equal to a sub 1, which is plugging in the lower limit, isn't it? So we already know it, it's 5. And then 1 minus our r is negative, oh, I need parentheses, -2 raised to the 10th divided by 1 minus -2. And then you could just type it in. Does everybody see how that was pretty easy? Okay. Cool. Do I need to calculate? Let's hurry and tell me what that answer is. First one. That? Yep. Perfect. Awesome. Okay, good. So if I say find the sum this way, that was almost easier, wasn't it? Really, in all reality, it was almost easier. Okay, awesome. Do 1 through 7, and they make 1 through 7 easy. They tell you sum of 6 terms, so it's super easy. The ones on the worksheet. Ready, set, go. Okay, so we know that an infinite arithmetic series would look like this: 1 plus 3 plus 5 plus 7 plus ... We would not be able to find a sum because when would we stop adding? We would have no idea when to stop adding, correct? We'd be adding forever. We'd be summing them up forever. So it's arithmetic. You're adding 2 each time, so with this one there'd be no sum. You would never know when to stop adding. Now, infinite geometric series, you can find the sum of some of them. So here's when you can find the sum. So if your R, and I'm going to explain why in just a second, and it will make sense. Okay, so this is the rule. You have this on your formula sheet. So if it is geometric, it will have this explicit formula: a sub 1 times by some number raised to the n minus 1. So that's called our ratio. So this is the ratio, right? What we're multiplying by to get from one term to the next. If it's less than 1, it converges to a sum. That's the word you're going to use. So if it's less than 1, so if r is a half, Aren't you cutting the values in half each time? So they're getting smaller and smaller. Does everybody understand? You can find a sum. It converges to a sum, and you'll use this formula, which this formula is easy. Look at it. All you have to do is take a sub 1, the first term, divided by 1 minus r. That's all you got to do. But you'll want to put parentheses around 1 minus r. So that formula is like pretty much the easiest formula we've seen so far. So if it's infinite and it's getting smaller and smaller, or r is less than 1, it converges to a sum. Now if r is greater than 1, that means like if it was 3, we're timesing by 3 each time, we're getting larger and larger. You can't find a sum, just like with arithmetic. It's getting larger and larger. We have no idea when to stop adding. Does that make sense? So it's called it diverges. So if you've ever seen the movie Divergent, like those are the people that are like, the people that are considered divergent are the people that are like crazy and they can't control. Well, as this gets larger and larger, you can't control it in a sum. That's how I remember divergent versus convergent. So divergent is bad. You can't find the sum. And I'll make sense of this right here, of why this works. Yes. So you always look at the absolute value of r. So that's a good question. So think about this. If we were multiplying by -2, it's still getting larger by -2, so we would still never know when to stop adding it. Does that make sense? So I'm going to make sense of why this makes sense right now. Okay, we know that if our r is less than 1, it gets smaller and smaller, correct? So look right here. 1 plus a half plus 1/4 plus an eighth. Isn't this getting smaller and smaller? It's going to be plus a 16th plus 1 over 32. Are we just getting smaller and smaller and smaller and smaller? Till eventually we're dividing by something so large that we're pretty much adding 0. Does that make sense? Like for example, type into your calculator for kicks and giggles, 1 divided by 1,000. What does it say? Do you see how it's pretty much 0? Does that make sense, everybody? So that's why we can find a sum. When this is getting smaller and smaller, eventually we're pretty much just adding 0. So it converges to a sum. Does it make sense? If I take a piece of cake, a full cake, and I say, all right, I'm going to cut this cake in half for the rest of your life. How much cake do you eat? We're going to cut the cake in half the next day. Here's a half a cake, correct? Cut that in half again. The next day, you're going to have this much cake. Cut that in half this. Pretty much on this day, are you going to have any cake to cut in half? So then eventually you're going to say, okay, we don't have any cake anymore, so we can add that up now. Does that make sense? Okay, good. Awesome. Okay. Oh, okay, yeah. So once again, let's check our R, which, I mean, you just look at it and say, this is getting smaller and smaller, so it's approaching 0 eventually. So it's going to get so small, so we can actually find the sum. And you can just use this easy formula. Let's do it. The sum is equal to a sub 1, which is 1, correct? Divided by 1 minus r. What are we timesing by? Yep, so 1/2. So type that into your calculator. What do we get? Use parentheses. 2. So guess what, guys? That adds up to V2. Converges to 2. Everybody good? Awesome. Let's do this one. Can I find the sum? No, it's getting larger and larger. When are we going to know when to stop adding? We're not going to know. Does that make sense? So our r was greater than 1, so we cannot find a sum. So no sum, we'd say it. Remember the word? Ooh, diversion. Yeah, diversion. No, they converge to a sum. It's just you're going to be pretty much at some point adding 0. Does that make sense? Like what I meant was this starts approaching 0. These numbers start getting closer to 0. Yes, no, those numbers will always, because it'll be 1 divided by some number, and it's going to keep getting larger and larger on bottom. Does that make sense? Yeah. So yes, these will always approach 0. So then it adds up to a sum. Good question. All right, let's do this one. So it says find the sum if possible. So let's check our R. What are we multiplying by? Now let's do it the good old-fashioned way. This divided by this divided by this. So type into your calculator if you need to. 9 divided by 8, in parentheses, divided by 3 divided by 4. 3/2. Is 3/2 greater than 1 or less than 1? Greater. What's that decimal, guys? 1.5. Isn't this getting larger then? So we're not going to be able to find a sum, correct? Okay, so you'd say no sum, it diverges. Just getting larger and larger. We would not know when to stop adding. Okay, looking at this one. What's our R? This divided by this divided by this. 1/3, isn't it? Yep, negative 1/3. Now, you don't look at the negative. The negatives doesn't matter. You only look at the absolute value of that. So is 1/3 less than 1? Yes, so it's actually getting smaller and smaller here. So we are going to be able to find the sum. So yes, we can find the sum. It converges to a sum. Let's find out what it does. So we would use that formula. What is this going to add up to be? So the sum is equal to a sub 1, which is 1/3, divided by 1 minus the ratio, negative 1/3. So now you'll just type it in if you need to. Yeah, in the equation, our R is negative 1/3. Yep. So what does that become? And make sure you use like parentheses up here, guys. What'd you get? 1/4. Cool. So you guys, that literally adds up to be 1/4, which is crazy. Does that make sense? Pretty cool though. Okay, number 28 on the homework. Go to your homework. Number 28. Here we go. So notice, this is an infinite sum. Look, here's the sum sign. That means find the sum. We're starting from 1 to infinity, so it's infinite. So you're going to have to say to yourself, can I find the sum of this or can I not? Notice it's geometric because it's exponential. So we'd say, okay, we're starting with 5, and then 2/3 is what we're multiplying by each time, correct? Is 2/3 less than 1? Yeah, so we're going to be getting smaller and smaller each time. So you'd say it converges to a sum. And that sum is, let's use our formula. The sum is equal to a sub 1 divided by 1 minus r. We've got to figure out our first term, so plug in the lower limit. So won't that be 1 minus 1? 0. So that would go away, wouldn't it? So 5. So we're going to have 5 divided by 1 minus, isn't this our r? Yep. 2/3. So now you'll just type that in. That's literally what it will add up to be. Yep. It sums out to be 15. Pretty cool. All right, so what I want you to do is 8 through 17, 22 through 31, ready, set, go. Watch, so we can go through this quickly and then it makes sense, because the hardest part with the story problems is figuring out what it's saying. So everybody look at my example. This is not on your worksheet, but I'm going to make sense of it for you. It is you want to save, it's supposed to say you want to save money for a vacation. You set aside $100. Then you set aside 10% more each month. How much money will you have in a total of 12 months? Are we going to be summing them up? Think about it. You want to know how much total money. So you say this is a sum. Is it infinite or finite? Do you know when to stop adding? After 12 months. Does everybody understand? So you'd say, okay, I'm finding the sum of a finite. Isn't it geometric since we're timesing by 10%? Okay, so you're going to be using this formula. You'd be doing S of n is equal to a sub 1 times 1 minus r raised to the n divided by 1 minus r. Now careful here because we're setting aside 10% more. You can't use 10% here. It's 110%, isn't it? The next month will be the whole amount plus 10 additional percent. Does that make sense, everybody? Okay, so a sub 1 would be $100. So you'd say 100, and then 1 minus 1.10, 110% raised to the 12, divided by 1 minus 1.10. That's how you do this one, and you would get $2,138.40. Make sense? Okay, next example. It says a pendulum has a first swing of 100 centimeters and its return swing is 99. What is the total distance the pendulum has traveled when it comes to a rest? Do we know when to stop adding? We said we knew that the first one was 100, the next one was 99, and then isn't it just going down till eventually it approaches 0? Till the pendulum is swinging no more. Doesn't that make it infinite? Okay, so you'd say the sum is equal to a sub 1 over 1 minus r. What's my first swing? 100. So we'd say 100 divided by 1 minus, what's the rate? You would do this divided by this, wouldn't you? 99 divided by 100. 0.99. It's 99% of its swing back. Does that make sense, everybody? So 1 minus 0.99. And then you type that into your calculator because that would sum up all the swings together. Does that make sense? Of what made it infinite. You didn't know when to stop adding, it just eventually became 0. All good? For the story problems. So that's 10,000 centimeters worth of swinging. Pretty cool. That's like such a good real world problem. I love it. Because that's like actually what you would see. And at UVU, they have a pendulum swinging. Yeah, it's so cool. Anyways, okay, so you're going to cross out problems 33 through 36. Do that now so you don't go home and forget to do that. Cross out problem 33 through 36. Note on problem 21, the rate is not 10%, just like in my example. That's all you gotta know. Make sure you don't just skip the story problems. That's why we learn this, is to be able to do the real world problems. So everything else is due though, but not 33 through 36. Just you'll cross those out. What? Well, what's the R? Not the R. Correct R. It's 90%, just like in this example, right? We didn't use 10%. Oh, right here it says it's going down. You got to read the problem and then you'll see. So it's 90% of its worth. Yeah, because it said 10% more. This one will say 10% less. Does that make sense? So you'll have to use 0.90 because that's 90% of its worth. Does that make sense? Okay.